Okay, in this section, we're going to show you how to do a two-sample dependent or paired t-test. It is a t-test because basically you have only a small sample. You don't know the standard deviation. In addition, it is paired because you have a before and an after scenario. So you can see right here, I have a before, I have an after. So that basically means a treatment has taken place. That means we measured a variable, we did something, we're measuring the variable again. So as you can see, I already have the whole problem worked out for us here. So the claim is right here. A scientist claims that pneumonia causes weight loss. So pneumonia causes weight loss in mice. Now it says let the mu of d, or the average difference, be hypothesized mean. So we're thinking weight loss, basically before minus after. So HO would be that their weight stays the same or goes down, and HA would be that their weight goes up. Okay, so we are going to be testing it in that particular way. We think it's going to either stay the same or go down, or it's going to go up. So that's how we get our hypothesis. So this is a one-tailed test. Now to find the critical value, we have to look as follows. We have 6 variables, or 6 mice, so that's 6, one less for degrees of freedom. So our degrees of freedom is 5. Our alpha level is 10%, and because of our hypothesis, we have a one-tailed test. So therefore, looking at our table, one-tailed test, 10%, degrees of freedom of 5, should give us 1.476, and that's how they get the hypothesis. The critical value for the hypothesis. So if t is greater than 1.476, then we're going to reject the null and go with the alternative. So now we need to calculate the average difference. So what we're going to do is we are going to come over here to StatCrunch. We're going to open it up in StatCrunch, and all my variables should come out. Now this is how we compute the average difference. Stat t paired. This is a paired sample, or a dependent sample. They're paired together. So when I choose this, I'm going to have the before column. I'm going to have the after column. Now this is very important here. You want to click Save the Differences. You want to click this button because it's going to make a column that shows you the differences between the before and the after. And that'll come important in just a few seconds. So I'm going to hit Compute. And you can see that my mean right here, this is the average difference, is 0.11666. That's how they get 0.117 right over there. Okay. Now, they need the standard deviation of the differences. Well, you don't really have that in this test. You don't have the standard deviation of the differences. But do you remember when I said it was important that you click the Save Differences box? Look what showed up right here in this column. I now have all of the differences. So in other words, I took the weight before minus the weight after, and this is the differences. So I have a bunch of numbers right here. So what I'm going to do now is I'm going to go to Stat, Summary, Columns, and I want to know the differences, okay? And the only thing I want to do is I'm going to choose to get rid of all these. I want to get rid of them all. I don't need all those. But I just want the standard deviation. That's it. So when I hit compute, I get 0.075, which is how they get the value over here. That's because when I did this test down here, when I did the paired test, I made the column of differences show up, and then I did a summary statistics on the differences in order to get the standard deviation for the differences. So that's when they're asking for the S sub D, the standard deviation of the differences. I had to do that extra little step. So again, after I did this, here's what I did. I'm going to go through it one more time for you. I did stat t paired. I chose my before and I chose my after. Then I clicked this little differences button. And when I hit compute, it gave me an extra column, the same one again. Then to get the standard deviation of the differences, I came to summary of a column. I chose those differences and I said, just give me the standard deviation. That's it. That's all I want of that one. And that's how I got that number, 0.075, which comes over there. So now I have to finish the problem. You can see my t-test statistic is 3.796, 3.796 over here. And then I already have my critical value of 1.476, and I can compare my t-value, my critical value, and I reject the null. I can also look at it this way. If you're a p-value person, basically I'm in a p-value of 0.01 or about 1%. I have an alpha of 10. And since my p-value is less than my alpha, that basically means I'm going to reject the null and I'm going to go with the alternative hypothesis, which in this case, the weight after went up. Okay, I reject the null. There is enough evidence to support the claim that causes weight loss in mice. Now, if you're asking yourself the problem right now, and I'm looking at all these different numbers and all these different answers, okay, as you look, I reject the null, and this says the mu d is greater than 0. The difference is greater than 0. It's not saying that the difference of 0 means there was no change. Mu of d greater than 0 means there was a change between the two of them, and the change was significant. It was more than nothing. Okay, so do not sit down and think to yourself that like the amount of weight loss was 0. It's the amount of change, and in this particular case, the amount of change was greater than 0, so that means, statistically speaking, that this was working there. So just to walk you through again, as we wrap things up here for you, again, stat, t, paired, I select my columns, I want to make sure I click this button right here, I want to make sure I click the differences so that shows up. That gives me my paired t-test values. I'll use the mean, I'll use the t-test, I'll use the p-value, but to get that standard deviation, I have to run an extra test on this differences column. And again, that's summary columns. I want to choose that differences column, and all I want is that standard deviation when it kicks it out for me, and that's the number I'm going to use. So hopefully that's enough to walk you through a paired t-test in StatCrunch, and this will be good for a couple different problems you're going to use. Let me know if you do have any questions.